Hello guys, in today's video we're going to be talking about limit of a function. So here are a list of methods which we use to solve limit of a function. We have the direct substitution method, we have the L'Hopital's rule, factorizing, limit at infinity, rationalization. So in this video I'm going to deal specifically on this, this and this. So I've talked about limit of a function at infinity in my other video, so check it out. So we are going to be talking about direct substitution, factorizing and rationalization in this video. In another video I'll be talking about L'Hopital's rule. So let's begin. In these methods specific functions which we use these methods. So for direct substitution, when we have a function that is at least lowest point is broken down to this lowest point, we just use direct substitution. We put our value inside, so and we get our answer. So that is direct substitution. So here we have this question, lim x tending to 3x squared plus 2. So now what we are just going to do is that we are just going to substitute our x as 3 here. So we have 3 into 3 squared plus 2. So we have 3 into 9 plus 2, and that is 27 plus 2, which we have 29. So this is our answer. So direct substitution is a very easy method for solving limits, but you have to take note of the function which you use it for. When the function is you see that you can't break it to any form again, you will use direct substitution method. So now let's go to the next one. So we have factorizing method. Now factorizing method is used when we have a fraction. That is, we factorize the fraction so that we can break it down to its lowest form. So I'll show you an example now. So here is an example of a function which we use factorizing method. Here we have lim x tending to 2 x squared minus 4 all over x minus 2. So if we look very well, we can factorize this, and we can break this fraction down to this lowest point. So that's what we are going to do now. So we have lim x tending to 2. Now if you recall, when we have a function, or when we have something like a squared minus b squared, to factorize it, for us to factorize it, what we just need to do is we can use difference of two squares. We have a plus b and a minus b. So this is the easiest way to use to factorize this, using difference of two squares. So if you check here, this is a square and this is a square. So expressing this in square, we have x squared minus 2 squared all over x minus 2. So using difference of two squares now, we have x plus 2 x minus 2 all over x minus 2. So this is going to cancel out. So we have lim x tending to 2 x plus 2. So here, if you watch now, we have expressed it in the lowest term. So now we are going to substitute. So substituting, putting our x to be 2, we have 2 plus 2, which is 4. So that's our answer. It's just very. So here is another example using factorizing method. You see that we have a fraction, and we can factorize this and we can break it down to the lowest point. So we have lim x tending to 3. Factorizing this. Now we're calling method of factorizing quadratic equation. To factorize this, we have x squared minus 4x plus 4. Multiply this and this, we have 4x squared. So we look for two numbers that can multiply each other to give 4x squared, and add each other to give minus 4x. Those two numbers should be minus 2x and minus 2x. If we add this, we can get this, and if we multiply this, we get this. So now We are going to replace this with this. So we have x squared minus 2x minus 2x plus 4 all over x minus 2. So we have lim x tending to 3. We have factorizing this and factorizing this. What do we have? We have x into x minus 2 and minus 2 into x minus 2 all over x minus 2. Now going further, we have lim x tending to 3. So we are going to take one of these. So we have x minus 2. We are taking this and we are taking this. We have x minus 2 all over x minus 2. So this can cancel this. We are left with lim x tending to the x minus 2. So now we are now going to substitute. So we have 3 minus 2, which is 1. So that's our answer. So that's for using factorizing method. Now let's go to the next one, which is rationalization. Remember when I told you that each method is used for a specific function. So you have to look at the function first before knowing the method to use. So this rationalization method is used for a function having sod in it. So you recall, okay, let me give you an example. Here we have an example. Now, when we are rationalizing a sod, we first have to find the conjugate so that we can be able to break it to the lowest term and remove the sod from there. So for the conjugate of square root of 4 minus t, we have square root of 4 minus t plus 2. So we just change, conjugate is changing the sign from plus, we change the sign from minus to plus. If we have this to be plus, the conjugate of this would be minus. This is the conjugate. So since we have it to be minus, this should be plus, so that they can be able to cancel. So here we have lim t tending to 0. We have t all over square root of 4 minus t minus 2 into square root of 4 minus t plus 2 is square root of 4 minus t plus 2. So this is still the same as this. We just added this. If we cancel this out, we still get this. So it's still just the same thing. We just added this so that we can be able to break it down. So we have lim t tending to 0. We have t into square root of 4 minus t plus 2 all over. We can break this down using difference of two squares instead of using long expansion method. When we have a square minus b square, we have a plus b, a minus b. So you're looking at this is the same as this. So changing it to this, we just have to square this and put a minus sign. So squaring this, we have square root of 4 minus t all squared minus 2 squared. We now have lim t tending to 0. We have t into square root of 4 minus t plus 2 all over square root of 4. No, this square root will cancel. We are left with 4 minus t minus 4. 2 squared is 4. So this can cancel this. So we have lim t tending to 0. T into square root of 4 minus t plus 2 all over minus t. This cancel this. So we have lim t tending to 0 minus square root of 4 minus t plus 2. So now since it's at the lowest point now, we put our t to be 0. So we have lim t tending to, okay, we have minus 4 minus 0, square root of 4 minus 0 plus 2, which is minus square root of 4 plus 2. Square root of 4 is Square root of 4 is 2, so we have minus 2 plus 2. So we are left with minus 4. Which is minus 4. So this is our final answer. So that's for using rationalization method. I hope you enjoyed this video. Please don't forget to like, share, and subscribe. I'll see you in my next video. Thank you for watching.